Hello, I'm Teacher Melay and welcome to this lecture video. So our discussion today is about multivariate data analysis. So here, of course, we know for sure that like other statistical tests, this tool is also powerful tool for researchers, for data analysts, for statisticians, and for decision makers. And then aside from that, if this is applied properly, it can reveal relationship that otherwise would not be identified because of course of the limitations when you just use, for instance, univariate or bivariate. And before we move to how to generate data, what to do, or the assumptions in using the different multivariate data analysis, we must need first to know important things like what multivariate analysis is and when its application is appropriate. So as I have mentioned, this is also used by decision makers. So in an organization, for instance, so they could create knowledge and thereby improve their decision or to make decisions by using the generated result or analyzed result using the multivariate analysis. Aside from that, all statistical techniques that simultaneously analyze multivariate measurements on individuals or objects under observed investigation is called multivariate analysis. Okay, next. So we also need to consider the nature of measurement, scales, and their relationship now to multivariate techniques, as well as we must understand the nature of measurement error and its impact on multivariate analysis. So this is important that you know that your data is nominal, ordinal, interval, ratio, because of course, as mentioned even in the descriptive statistics lesson, this is one important things that we need to remember because this is our basis in determining what appropriate test is applicable for our data. So we must know that, for example, just like what we have mentioned in the previous video, that it is possible to use either parametric test if the data is at this interval, and it is also applicable to use non-parametric tests in case that your data is categorical. And then for its impact, so the researcher must identify the measurement because it can be that he or she identifies or applied incorrect statistical test in case that the nature of the data was identified incorrectly also. And aside from that, again, this is critical in determining which multivariate techniques are the most applicable to the data. Actually, we have two impact. The first one is that you might identify incorrect tests because of incorrect identification of the nature of your data. And the second one is that you might commit error in identifying. And then the second one is you might commit error also in identifying for appropriate test. So of course, this will lead to a wrong analysis. Okay, next. So we also need to determine which multivariate techniques is appropriate for a specific research problem. So how many are our dependent variables? Are both dependent and independent variables treated? So are both dependent and independent variables are being measured? And then we also need to define the specific techniques included in multivariate analysis. So that is, of course, we have to answer this question that can the variables be divided into dependent and independent variable based on the theory? Next, if they can, how many variables are treated as dependent in a single analysis? Next, how are the variables both dependent and independent variables being measured? So these are the questions that will be our guide also to determine what appropriate test is applicable for our data. So let us have this table, for instance, or rather figure. So the figure shows here what types of relationship is being examined. So if this is your question and your answer is dependence, or independent. So we have here guide. For instance, if it is dependent, so how many variables are being predicted? So if it is multiple relationship of dependent and independent variables, so it is possible that you want to work on structural equation modeling or several dependent variables in single relationship. So what is the measurement scale of the dependent variable? Is it metric or non-metric? So it is quantitative or qualitative or categorical. So what is the measurement scale of the predictor variable? Again, is it categorical or it is at least interval? So in case that it is metric, so it is possible is using canonical correlation analysis, while if it is non-metric, possible test is multivariate analysis of variance. So the same with here, if your question is, or the answer is non-metric, it means that you can use canonical correlation analysis with dummy variables. While if you want to work on one dependent variable in a single relationship, so the question is, what is the measurement scale of the dependent variable? So again, is it metric or non-metric? So if it is metric, then so you can use either multiple regression or conjoint analysis, while for non-metric, you can use multiple discriminant analysis or linear probability models. Now let us move to the next side of our figure, which is what if, so it is independent. So is the structure of relationship among, so let's have variables. Is it, so factor analysis, confirmatory factor analysis, or is it based on cases or respondent or objects? So structure of relationship among cases or respondents. So you can use cluster analysis. For objects, how are the attributes again measured? Is it metric, non-metric? So you can use multidimensional scaling or correspondence analysis. So these are some of the multivariate techniques. So just to name, so we have principal component and common factor analysis, multiple regression and multiple correlation, multiple discriminant analysis and logistic regression. We have canonical correlation and analysis, multivariate analysis of variance and covariance, conjoint analysis, cluster analysis, and perceptual mapping, also known as multidimensional scaling, correspondence analysis, structural equation modeling, and confirmatory factor analysis. So let us move to the guidelines for applications and interpretations of multivariate analysis. So we need, of course, to establish practical significance as well as statistical significance. So we are most commonly that we just focus on the statistical significance, whether to reject or accept our null hypothesis. But as much as statistical significance is important, it is also important to consider the practical significance. So next, recognize the sample size effect of all results. So as much as possible, if you are going to use multivariate or you are planning to use multivariate data analysis, you have a large sample size. So you must have a large sample size. And then for number 3, you have to know your data. Number 4 is strive for model parsimony. So for instance, including irrelevant variables. So Number 5, we'll look at your errors. So in case that you obtain, for instance, a model that is not a best fit model, or it is not the model that you are expecting, so um, you can analyze your data again, find out what's wrong with your data, so you can look at your errors. So what went wrong to the data. And then for number 6, validate your results. So you can consider, for instance, another sample to do that. So you can validate it by considering another group of samples. So if you can just see later if, or you can add it in your data. And of course, this is the 6-step approach to multivariate model building. So we have to go back to your research problem. We have to define the research problems, objectives, and the multivariate technique to be used. Next, you have to develop analysis plan, evaluate the assumptions. So you need to check if it satisfies the condition. And number 4, estimate the multivariate model and evaluate fit, interpret the variates, and validate the multivariate model. So this is my reference material. So thank you for watching.